Welcome all. Welcome to this low-level design playlist. In this series, we will dive deep into the concepts of low-level design, breaking them down step by step to help you build scalable and maintainable software systems. Whether you are preparing for an interview or working on a real-world project, understanding low-level design is crucial. This is the first video of the series where we'll introduce what low-level design is and why it matters. So what exactly is low-level design? LLD is the detailed step-by-step process of designing the internal structure of a system. It focuses on defining classes, objects, methods, and their interactions to ensure the system functions as intended. Think of it as the blueprint of developers, guiding them on how each component should be implemented. Let's understand it by an example. Designing a car system. If we take an example of car system, at a high level, we know that a car consists of multiple components like an engine, wheels, seats, and dashboard. But just knowing these components is not enough. We'll also need to define how they interact with each other. For instance, in low-level design, we break down the system like this. The car itself contains essential components like an engine and wheels. The engine is responsible for starting and stopping the car, so it will have methods like start and stop. The wheels must rotate when the car moves, so they will have a rotate method and a stop method when the car comes to a halt. By defining these components and their behavior, we ensure that the car system is well structured, modular, and easy to maintain. Similarly, in software development, LLD helps us design systems where different parts interact efficiently, just like a car's component working together smoothly. In the next section, we'll see how LLD differs from high-level design and why it is important. Now let's understand the key difference between high-level design and a low-level design. High-level design focuses on the big picture. It defines the overall architecture of the system, what components are needed and how they interact. For example, in a web application, high-level design would specify that we need a database, a web server, and a user interface, but it wouldn't describe the details of how these components are implemented. On the other hand, low-level design is all about the fine details. It describes the internal working of each component, includes class structures, methods, attributes, and relationships. In our web application example, LLD would define how the user authentication system is built, what classes and functions are needed, and how data flows between different modules. If some of these concepts feel a little abstract right now, don't worry. In the upcoming videos, we'll connect all the dots using real-life examples. By the end of this series, these concepts will become second nature and you'll be able to design software systems with clarity and confidence. Let us understand why is low-level design so important in software engineering. Let's break it down with a few simple reasons. Let's understand scalability. Imagine you're building an online shopping app. Today you have 1,000 users, but what if tomorrow you have 1,000,000? Low-level design ensures that your system is designed with modular, reusable components that can grow as your needs expand. Next is maintainability. Think of low-level design like writing neat and well-organized code. If your code is structured properly, making changes later becomes much easier. It's like keeping your files in a labeled folder instead of messy pile. Then there's quality. A well-designed system reduces error and improves performance, like a well-assembled machine. When each component is carefully planned, it runs smoothly with fewer bugs. And finally, efficient communication. Low-level design acts as a common language between developers, architects, and even new team members. If a teammate joins your project, they should be able to understand how the system works just by looking at the design documents. So if I put these things in simple words, low-level design makes your system scalable, maintainable, high quality, and easy to understand, which is why it's a must-have skill for every software engineer. Now let us talk about the key components of low-level design: classes, methods, and relationships. First, we have classes and objects. Most of us know about it. Think of a class as a blueprint and an object as an actual thing built from the blueprint. For example, if we are designing a car, we might have a car class, an engine class, and a wheel class. Each of these represents a real world entity in our system. Next, we have methods and behaviors. This is where we define what each class can do. The engine class have a start method to turn on the engine, while the wheel class might have a rotate method to start moving. These methods define the behavior of each component in our system. Finally, we have relationship between components. Classes don't exist in isolation. They interact with each other. In our car example, the car class contains an engine and wheels, meaning they are connected. We describe these connections using terms like association, aggregation, and composition, which define how strongly linked these components are. Understanding these three components, classes, methods, and relationship, is crucial for building well structured and efficient software. Don't worry about the terms association, aggregation, composition, classes, methods, and the relationship between them. We'll go deep into it in the upcoming videos. And that's a wrap for the introduction video to low level design. We have covered the basics of what low level design is, why it is important, and the key components involved. But this is just the beginning. In the upcoming videos, we'll dive deeper into more complex topics like object oriented principles and the solid principles, essential for writing clean, maintainable, and scalable code. And to top it off, we'll be working on a real world project, putting everything we have learned into practice. If you find this video helpful, make sure to subscribe so you don't miss out on the rest of the series. Also, leave a comment if you have any question or topic you would like us to cover in future videos. Thanks for watching, and I'll see you in the next one.